start looking at this. Okay, well, this part A is just given by matrix multiplication because this takes the vector here into this vector here. So we can just write A, the part is, I'm going to write symbolically first, GBB times XYB equals, well, UV some other. So we have to just solve this. We just have to do the matrix multiplication here, which is 2, 1, minus 1, 0 times XY equals 2x plus y and minus x, right? And this is in basis D. Now, why do I say D? It's in basis B. Got D in my mind somehow. Okay, so now if we want to know what it's in part B, so that's the answer to part A. The answer to part B is, well, what is, if I take XY in basis B, that is X times 1, 0 plus Y times 1, 1. That's what this notation means. It means X times the first basis vector plus Y times the second one. So I can write that as X plus Y and Y, right? So if I wanted to start from some vector, I'd have to go the other way. So I can see that I go back and forth, or I could ask, if I want to start from some vector here, this is in vector E, but I actually want to know, here's the vector in the standard basis. What is that in terms of basis B? Well, that's going to be R times 1, 0 plus S times 1, 1, which equals R plus S, right? Well, okay, that just goes back and forth here. What I want to do is I just want to say, okay, well, I want to solve for R and S here, right? In terms of X and Y, and this is just going to equal RS in basis B. So I want to solve the linear system 1, 0, 1, 1, XY for X and Y, for this is for R and S, because that's going to be the form. So this is going to start from XY in the standard basis. We translate it to its representation in basis B, and that means solving this linear system. Well, it's already in echelon form, so we can see that S equals Y, second equation, right? And then R plus S equals X, or R equals X minus S, which equals X minus Y. So therefore, XY in the standard basis equals X minus Y and Y in basis B. Okay, do you see that? Okay, let me say it again. We want to know, we want to find this, we have to start from a vector in the standard basis. We start from a vector in the standard basis and find its representation in basis B. That means writing it as a linear combination of vectors in basis B and solving for R and S for the coefficients. So we do that, and we find that this result here. Okay. Now, we have the action of the matrix 2, 1, minus 1, 0 on any vector in basis B. So in particular, we can do this one. We can take 2, we can do 2, 1, minus 1, 0 times x minus y times y, right? Because this is taking us from B. We know the matrix is B to B, so we took the matrix, we took the vector in standard basis, put it in the form the matrix could act. Then we do the matrix multiplication, which is going to be 2 times x minus y plus y times 1. That's 2 times x minus y, 1 times y. Then minus x minus y down here, plus 0 times y. And this is in basis B. Okay, so we can simplify that then. Up here, this is 2x minus 2y plus y is 2x minus y, right? Because we've got minus 2y plus y. And then down here, that goes away, and it's just y minus x in basis B. Did I do the arithmetic wrong?
Oh, no, just to keep it consistent, could you just do like negative x plus y, or would that matter, or? 2x minus y and then negative x.
2 times x minus y plus 1 times y is this, minus 1 times x minus y plus 0 times y.
Yeah, the equation y minus x is correct.
Down here?
When we need to do negative x plus y, they don't change anything or what?
Oh, no, we could leave it this, we could, in fact, let's do it so we don't, that sort of violates one of our rules. We could have minus x plus y. Let's leave it like that so it doesn't confuse. Okay, so it's not going to matter, but so the point is though, if we want to find the image in the standard basis, we don't have it quite in the right basis. So we have to then take this and say, well, what does this mean? It means 2x minus y times the first basis vector plus minus x plus y times the second basis vector. That's what this notation means. Okay? So I've just written this expanded in the second basis. Now, I can then simplify this because this is going to be 2x minus y 0 plus minus x plus y minus x plus y over here, which equals, I add them together, 2x minus y plus minus x plus y. Well, I'll just write out, then simplify it even. Right, and the bottom one is 0 plus minus x plus y. Now this is in the standard basis now, because I'm given this basis B in as vectors in the standard basis. That's how I know what it is. Okay, so then this one is 2x minus x is x, minus y is y, and this bottom one is minus x plus y. So this whole thing, we start from x, y, implicitly in the standard basis, and that the map is x minus x plus y. This is, what did I call the map? G. This is the map G. We could, for consistency, we could go back and ask, we could go back, sort of rerun the whole thing, and what is this, the matrix of this map in basis B, right? Then we'd have to expand this in basis, take this back to basis B, take this back to basis B, and we could do, and then we could find, because we want to find the basis action you'd want to find the image of this map under what is the basis action of 1, 0. Well, that goes to 1, 1. And what's 0, 1? That goes to 0, 1, right? Okay, but this is in the standard basis. So these aren't the columns of the matrix. We'd have to expand this in terms of basis B. And this one. And then the matrix you want would be R, S, T, and U.
Would sorry, for the basis action on 1, 0 would it be 1, -1? The image.
Oh, let me see, X. Yeah, 1, 0 would be 1 minus 1 here, yes, because it's X minus 1. And this one would be okay, there we have it. Now, so we could see what this, like the first one is to solve these would be 1, 0, 1, 1, 1 minus 1, right? For R and S. So we say S equals minus 1 and R equals 1 minus a minus 1, which equals 2. Right? Because if S is minus 1, R has to be 2 because 2 plus minus 1 is 1. If you want to do it, you look puzzles. And
Can I just scroll up there?
R plus S equals 1. So R equals 1 minus S, which equals 1 minus a minus 1, which equals 2. Okay? So I know that R equals 2 and S equals minus 1. So the first column, that means that 1, 0, this is the vector in basis B, goes to 2 minus 1 in basis B, and then we'd have to do the second one here. We'd have to do 1, 0, 1, 1 equals 0, 1, I think. And this would be, again, T and U, and so U equals 1, and T would have to equal minus 1. So therefore 0, 1 goes to minus 1, 1. I think. Although it sounds like I've made a mistake somewhere. Because I should be recovering. See, this one I do, this 2 minus 1, I do recover this, but I don't get this 0 here. So there's somewhere along the way that I have. Oh, okay. So somewhere along the way, this one here, let's make sure 0, 1. 0, 0, 1, okay. Then T 1, 0. I want this to be 0. Why is U did I get so somewhere along, that means that somewhere up here beforehand I probably I could have made some mistake up here. So let's yeah, it could be. Let's see. But we have to go back and find the error, which let's see. let's see if we can see. Well, this one here is 2x plus y minus x, so that's correct. And then to find this, we'd have to we have to take xy. Xy is going to be x plus y and y, and then we have we actually want it the other way around. We want x, y is extent, r and s, so we do x and y. Oh, yes, so let's see. Okay, this is already in echelon form. So we have s equals y. So that's okay. And then we have r plus s equals x, r equals x minus s, r equals x. So this looks correct. And we can do the multiplication here. So it could be in somewhere in here. We have 2 times x minus y plus y and minus x minus y plus 0. So that looks correct. 2x minus 2y plus y is 2x minus y and minus x plus y. And what this means is 2x plus y here, 2x minus y and 0, and minus x plus y, minus x plus y, and x, that cancels. And this one is just minus x plus y. So it looks like this is correct. So I may have to puzzle over this after class, not if I can't spot what. So because I look at the image of, of course. Yes, okay, so I made an elementary error. We're looking at the image in basis B. Well, this is V1 in basis B, right? But the second one is, we didn't want, I took the standard basis here, so there's the error. I wanted here the image of V2 in basis B. So this one is 1, 1, right? That's going to go to, if this is going to go to x and y are 1, that means this is 1 and minus 1 plus 1 is 0, which is quite a bit different in effect, which is also going to solve the problem here, hopefully. Yes, and it does right away. Because you can see here that s equals 0, right? And still r plus s equals 0. So r plus s equals 1. Since s is 0, r is 1. So, okay, so this is not R and S. Sorry about that. Jumping the gun. This is T and U because we're doing the second one. So therefore, U equals 0 and T plus U equals 1. T equals 1 minus U, which equals 1. So U equals 0 and T equals 1. Okay, so I think I've gotten, let me see if I can, I think I've edited the wrong one. So I'm going to use my back thing here to, yeah. So I was editing the wrong one. So there is the top one, and then I'm going to TU, and so this one was 1, 1 here going to this was 1, 0. This is correct. But we go to the next one, and we have this is follow up. The image here is 1, 0. Okay. Sorry for your notes that you've, therefore u equals 0 and t plus u equals 1 and t equals 1. And we have 1, 1. Going to t and u. So this is t is 1 and u is 0 in basis B. And therefore, we get that the matrix G is going to be 2 minus 1, 1, 0 from B to B. So, and that is the matrix that we started with, 2 minus 1, 1, 0. This wasn't part of the problem. This was like by going it backwards and saying, okay, if we started from this, if we started from the form, we should be able to recover the matrix B to B here. And then so I made a mistake in terms of I found the image of the standard basis vectors, not the image of basis B. And when you go back and do the image of the vectors in B, that gives you the matrix G. So everything works out. So I apologize for the, but maybe hopefully it's an instructive error rather than destructive of your understanding. So you guys, is that, maybe you have to go back and work through it again to sort of see what's going on. Okay? Because you have to sort of go slowly, and if you can see if you it's like the calculations you're doing are not complicated, but they're conceptually tricky. Because you can lose track of what basis you're in, what's going on. Okay, so